Okay, this video is about like some gotchas I encountered in Clojure. It's for number comparison. So let me just dive in, right? So when you compare, let's say 7 with 7, and it's definitely true, right? So that's the thing, right? And let's say like when you compare 7 with 7.0, uh, your mind knows it's true, but according to Clojure, it's false. Okay, so that's how it is. And let's say we just compare, okay, like 7 with 7/1. Like 7/1 is a rational number in Clojure, and that's true, right? So this gotcha you need to remember in Clojure while you're doing. So whenever it's a double, like yeah, this one fails. So the only way to correct this is like, okay, like you can put something like this one, like uh, double of 7, and then this is equal to 7.0. So if you just put like this, now you'll get true, right? So like, yeah, that is what I mean to say is like, okay, yeah, like if the decimals matches, it's uh, it's equal. So 7.0 is equal to 7.0. So no doubt about that. Okay. So that's how it is. And I don't know, like my AI, what to say, said something like M or something like this. I don't know what this M means. Let me just uh, try it out. 7.0 M. I don't know what the 7.0 M is like. Let me just put type of 7.0 and it gives double, and what does M means? Oh, okay, it means big decimal. Okay, okay. So then I've got another idea. Let me just try like, okay, like 7.0 equal to 7. This is also false. Okay, so it looks like when it comes to floating point or something like that, Clojure also looks for what to say, like the type. Even 7.0 is not equal to 7.0 M. That's because in internal computer memory, it's been represented as something like it is very difficult to represent floating points in computer memory, and that's why these comparisons are not coming correct. Okay, so that's the thing. So one way to do is like, I don't know, like maybe convert this to double, like okay, like not this one, like yeah, you can convert at least one thing to double. So does it even work? Yeah. But I don't know, like look, big decimal could be much more larger than double, but yeah, like I will do another video about it, like how numbers are being put inside computers, and what those binaries are, and why it is very tough to what to say, like uh, represent some numbers in computers and all those stuff, right? So for example, like if I just put like double of uh, uh, 1/3, right? Look at this number, right? So and it goes on till infinite. This 3 is just goes on till infinite, just for your sake, just for showing it on computer. You're just showing it like this with so many threes or something like that, right? So maybe we can find the length of threes. Okay, so I just take it, okay, like put something like count and pass it as a string. Yeah, it's 16 threes, but in fact it goes till infinite. Okay, so that's the thing. So I don't know, like yeah, so it is very difficult to represent all this ratios in computers and what to say. So that's why, like, yeah, Clojure doesn't do very, or Clojure or whatever programming language doesn't do very well with this floating point comparison, and you need to have that in mind. So if you're having floating point, just convert all the numbers you're comparing into one particular type and then compare, right? So that's one advice I can give to newbie clojurians. Okay, so that's the thing. So I just want to make a very small video about this. Yeah, hope you just got the hint of it. And yeah, I will start making some videos about how numbers have been represented in computers, right? Anyway, thanks for watching my video. Until we meet in next video. Bye.